When we start talking about virtual reality, what word will emerge firstly? I suppose most of people will say game. As a cutting-edge technology, VR creates a brand new experience for game player, making you in the game instead out of the game. This is truly a revolution in the game industry, but we still can extend its ability to a further place, like education and medical field. Or we can just throw out the game concept and just use virtual reality technology to construct professional applications for these fields. In this video, we will introduce the virtual reality's application and focus on the education and medical fields. Before talking about virtual reality's application, let's see what VR actually is. VR is defined as a simulated experience with the usage of computer technology, which can be similar to or entirely different from the real world. There are three principles of virtual reality: human-computer interaction, data modeling, and display. The human-computer interaction system mainly relies on hardware and captures the user's action in real time as the input data of the VR system. Motion tracking technology is the core of human-computer interaction. There are four motion tracking technologies: eye tracking, head tracking, hand tracking, and full body tracking. However, head tracking and hand tracking are the most popular. Eye tracking technology can be used to ensure the best adjustment of the virtual camera for each eye, but it's hard to achieve a great performance because of high-speed eye movement. Then, we mainly use head tracking for vision tracking. Full body tracking is the best for body tracking because it includes the tracking for many joints of human body, not just hand, which could make your virtual experience much better. However, due to the price of the horseshoe kits and most of applications only support hand interactions, hand tracking is a more popular option than full body tracking. About data model, it includes two parts: structural models and computer graphics. The structural model is a set of data that represents the visualization object. A virtual object has many features, such as shape, material, and several physical characteristics, and we often use boundary representation or construction of solid geometry to represent it. Computer graphics is used to render graphics before visualization of virtual models to enhance the authenticity of objects and the immersion of users. The key point of this part is simulating the interaction between the virtual lighting and the virtual objects, which could make users' experience more similar to real world. The core of display part of the VR system is multi-sensory feedback technology. As we know, vision is a significant part in VR system because it gives the most information to user. In common case, the display is just a flat vision, but we need stereo vision in VR. To achieve this goal, there should be two virtual cameras in virtual environments to mimic two eyes, and transform two images obtained by cameras to a stereo vision. What's more, the resolution of display is also important because VR's target is to make the virtual world more similar to real world. Since the resolution of the eye is close to 1 arcmin, the image needs to be displayed at a corresponding resolution. If the resolution is too low, we will not only lose details of objects, but also make users feel not comfortable because of lag.
After understanding what virtual reality technology is, let's take a look at what we can do with VR technology in our real life. While it has many applications in different aspects, our group just focused on education and medical field. Let's start with the application of VR in education area. Nowadays, VR technology has been used in some subjects. For example, in the astronomy class, students can observe the universe, galaxy, and Earth more intuitively. In the application of biology teaching, we can observe the inside of a cell like watching the structure of DNA. These are very vivid. In addition, VR technology can also be applied to create historical scene. Students can be put personally into such scene and experience the historical environment at the time as a bystander, which helps students achieve a greater understanding. The application of VR technology in education stimulates learners' interest and hobbies and also deepens their understanding and memory of related knowledge. But at present, it is not applicable to all disciplines. For some abstract knowledge, such as logic and some concepts that appear in mathematical algebra, it is hard to express with VR. Next, I'd like to introduce the application of VR technology in the medical area. The first instance is virtual reality anatomic visualizer. As we all know, organ samples have always been rare resources in medicine. Fewer organ samples result in most surgeries relying more on theory rather than practical application. And the unfamiliarity with the actual operation may lead to an increased risk of surgery. Under such situation, the University of California proposed to use VR technology to generate virtual organs for surgery practice. Now, VR technology is already being used in some anatomy learning centers. In the video, we can see that people can wear active glasses to observe different kinds of organs and anatomies in a special VR room. They can even use handles to simulate the surgical process. Obviously, VR technology has greatly improved the medical learning environment in all aspects. First of all, this technology allows students to perform surgical simulations many times until they can operate proficiently. In addition, since the operation process is completely virtual, medical staff do not have to worry about potential safety issues, such as the infectiousness of certain diseases and preservation of specimens. However, we can see that the handle used for training in the video is not a real scalpel, and this kind of handle cannot provide a real sense of touch. This deviation may affect the accuracy of the actual operation. Secondly, I'd also like to introduce virtual reality rehabilitation of post-stroke. Let's watch a video first to learn how VR technology can help stroke patients with rehabilitation training.
After suffering a stroke, you may lose the use of a hand, which is a disability in daily living. Therapies used for long-term rehabilitation include mirror therapy, biofeedback, and observation of movement. Based on the motto, "We believe what we see," these therapeutic approaches can be merged and put into a virtual world. With PSI, both the active hand and the paretic hand are perceived as active, functioning hands in the virtual world. While the active hand can be used just like in the real world, the virtual movements of the paretic hand are animated. If the affected hand is completely impaired, the movements will be artificially animated. If some functionality remains in the affected hand, the virtual hand is controlled by its EMG signals. Within this virtual world, the patient carries out task-oriented and repetitive challenges, in which both hands are active. The aim of this interactive illusion is to provide the best possible stimulation of neuroplasticity to support the rehabilitation of the paretic hand.
At present, some nursing homes have started to try some treatment methods combined with VR technology. We can see in the video that when using VR technology for treatment, patients will be trained through some friendly human-computer interactions such as games. This technology can increase the fun of rehabilitation training, which also helps patients maintain a positive attitude towards training. However, at the same time, some patients also reported some halo 3D reactions when using this technology. So it is not suitable for everyone, but it really needs some help.
As a brand new method for knowledge transfer, VR technology simulates various perception points by providing a more attractive environment than the traditional method, which shows great potential in the education and medical fields. However, it's still far from perfect. Some VR applications nowadays still suffer from high latency of information processing and errors in the delivery of virtual objects. All these obstacles are stumbling blocks to the development of VR technology, and need to be resolved in the future.